The second application is the coastal fog harvesting tower in Chile. Instead of hanging a 2D mesh like we introduced before, this project used a 3D tower to harvest the fog from all directions. And they also use a specific spiral wooden structure to withstand the strong wind. So on the right is the structural model they're building right now. The final goal is to build a 200-meter tower to harvest the water from the Huasco River in Chile. The next application is collecting fresh water from power plants. Every year, about 40% of fresh water collected from rivers, lakes, and reservoirs in the US is used for cooling in electric power plants. And much of the water ends up floating away in clouds of vapor. So a team from MIT used technology Hansong introduced before to collect more water. So as shown on the bottom left, they use an electrode to emit the ion beam, and so the water droplets are ionized and they got pulled towards the wires. Let me show you a video as well. So this is a normal mesh without any ionized droplets. Now they ionize the droplet and all of them get pulled to the mesh. This is super efficient and it will save around 20 to 30% of water lost from cooling towers. You will also save millions of dollars for them. Another invention inspired by the beetle is the dew bank water bottle. It is made of water with cold. It's made of metal with cold property. So in the early morning, the water will be gathered to the surface because it's colder than the air. And the uneven surface is just to increase the surface area to collect more water. And the water bottle can also be used as a basket or gourd. So it's very useful. However, this is only a design and haven't been commercialized yet. The last application I want to talk about is related to hydrophilic and hydrophobic material. So it's very widely used in our daily lives. For example, Nike's dry fit technology use a hydrophilic material inside to absorb the sweat and then use hydrophobic material outside to vent out the moisture so that your clothes can stay dry for the whole day. It's called moisture wicking technology. Now I'd like to conclude our presentation. So harvesting water is very important, especially in some dry area, and especially when the water is not being replenished due to climate change. And there are actually a lot of applications inspired by the fognet and desert beetles. Researchers are also trying to improve the technology and techniques to collect more water. So for example, structure-wise, Hansong talk about they improve the structure to prevent water droplets from clogging. And material-wise, they're using more stronger material to withstand the strong wind. And electrical-wise, they are using electric static force to collect more water. However, there are still a lot of work to do to work on. For example, the prices are still very high. For example, the fog collector costs around 600 euro per piece, which is around $620 for one piece, and it's only 1 square meters area big, so it's very expensive. Environmental influence is that all the meshes are made of plastic, so maybe in the future we can find a better material that is more environmental friendly. Lastly is the safety consideration. So if we want to drink the water from the fog collector, maybe we need to use some material that are food safe and also that can prevent decompose from UV light, and also to prevent the fungus from growing on the mesh. So yeah, that's all for our presentation, and this is the reference. Thank you so much.